Okay, hello everyone. I am Somik Chakraborty. So, welcome back to my channel. So, in this video, I will share the PhD interview questions that were asked to me and one of my senior Orkomitroda from my lab. I gave interview at ICS, SINP, and my senior Orkomitroda gave interviews at ISI, ISCS, and one IIT. Honestly, I cannot remember the exact name of this IIT. Okay, now I am going to discuss the real questions, experiences, our experiences, and some tips, some useful tips that can help you in your own interviews. Okay, so let's start. Okay, so before start, I want to say something. So I have a small request to you. Okay, so during my MSc I learned a lot from free YouTube videos. Okay, lot of physics from free YouTube videos for cracking national exams and interviews, and I always supported those channels by subscribing them. Okay, if you find my video useful and you can learn something from it, please subscribe to my channel. It will really motivate me to make better videos to help students who are preparing for cracking national exams and interviews. Basically, my main motto, main motivation is to help those students who are working hard but do not get proper guidance. Okay, so if you learn something from my video, please subscribe my channel. Okay, so let's start. So at ISCS, there were 4 professors: Krishnendu Sengupta, Arnob Das, Arnob Sen, and Indra Dasu. I think they are the gold of theoretical quantum matter physics in India. Okay, firstly, Krishnendu sir asked me why did I shift from gravity to quantum matter physics, and basically I did my project under the supervision of Professor Sumanto Chakraborty in quantum cosmology. Okay, and after my MSc I decided to shift in theoretical quantum matter physics, so I told them clearly. So in front of you I cannot share this type of things. Okay, then next Arnob Das asked me a good question. Consider a particle of mass m that moves on a rigid ring of a radius r. Find the energy, eigenvalues, and eigenstate of the quantum system. Okay, this is very good questions. You can you have to face in different competitive exam, GATE, JEST or NET. Okay, and I remember that when I convert the Schrodinger equation from Cartesian to circular basis, okay, I feel some problem, but finally I took 5 or 6 minutes and I derived it properly. Okay, you need to handle this problem, okay, in your MSc. Okay, so then they asked me to plot electron occupation function versus energy at t equal to 0 Kelvin and t greater than 0 Kelvin. Okay, and Arnob Das asked me a few tricky questions about how specific heat and metal depends on temperature. Basically, they asked me about the CV proportional to T condition for contribution of fermions in the specific heat at low temperature. Okay, and they also asked about few questions, range of atomic energy level and which corresponds to temperature. Basically, range of atomic energy level is eV, electron volt, and if you put 1 electron volt is equal to kBT, from this equation you can find the range of absolute temperature. Okay, so these are the questions I faced in ICS. Okay, these are the summary of the questions, interview questions. Okay, I also appeared at SINP, Saha Institute of Nuclear Physics. They asked me about my favorite topic. I told classical, quantum, and statistical and mathematical physics, and they first asked me to write down the Ising Hamiltonian. I wrote down, and they told me when j greater than 0, j less than 0, or sign of j, about these things. Okay, you need to think. When j greater than 0 we get ferromagnetic ground state, and j less than 0 we get antiferromagnetic ground state. So you need to think these things clearly. Okay, and they also told me to write down the partition function of this system and magnetization, to calculate magnetization and susceptibility. So you need to remember this formula clearly, properly. Okay, otherwise you cannot solve it. And then they asked me a few good questions. For a pentagon with nearest neighbor interaction Hamiltonian, find the degeneration of the lowest energy ground state. Okay, I think you also faced this type of question in CS and NET. Okay, when J greater than 0, this is very easy to find the degeneration of the ground state. But when J less than 0, I think you feel some trouble or problem to find out the degeneration of the ground state. Okay, I struggled when J less than 0 case. Okay, I could not get the correct answer when J less than 0 for this question, for that find out the degeneration of the lowest energy ground state. Okay, and they all lastly they asked me which topic in theoretical condensation physics I want to research. Basically I told them that I did my project in quantum cosmology, and so I cannot decide, but I feel good in superconductor about these things, ferroelectric, multiferroelectric, these things, and I told them this type of things. Okay, but as I did project in quantum cosmology, I could not tell this answer properly, which topic I interest in theoretical condensation physics. Okay, I just appeared at two institute, ISS and SINP, and I am selected by both. I did not appear more institute because I did not want to go outside Kolkata at that time. Okay, and I also discussed one of my lab mate, one of my senior, Mitruda, he appeared at ISI, ISS, and one IIT for interviews. Okay, and he cracked these interviews. Okay, at ISI, Indian Statistical Institute, he faced these questions. Firstly, they asked him, when do we obtain discrete and continuous and mixed energy spectra in quantum mechanics? And they asked him which quantity is conserved under unitary transformation. And they gave him this matrix. This is a famous matrix. Okay, only one row is independent, other row is dependent on the first row. Other rows are dependent on the first row. Okay, so they told him find out the number of non-zero eigenvalues and zero eigenvalues without performing any direct calculation. Basically, from this matrix we can easily say the rank of this matrix is 1. Basically, number of independent row is 1 in this matrix, and number of independent row is equal to number of non-zero eigenvalue. Okay, as it is a 4x4 matrix, we get 4 eigenvalues, and as rank is 1, only 1 non-zero eigenvalue will get and 3 zero eigenvalue will get. Only possibility. Okay, only 1 non-zero eigenvalue and 3 zero eigenvalue. So you need to handle this type of problem. You can also face, you have to face this type of things in your different competitive exam. You have to face, okay, this type of questions. And ISI, he also faced these questions: what is the Bose-Einstein condensation, and difference between gas-liquid condensation and Bose-Einstein condensation. I think this is very tricky question. Basically, the answer will be the gas-liquid condensation occur in real space, okay, and Bose-Einstein condensation occur in quantum space or momentum space, and gas-liquid condensation occur in T is equal to 0 Kelvin. Okay, finite temperature, but Bose-Einstein condensation occur in ultra low temperature, and gas liquid condensation is a classical phase transition. Okay, and Bose-Einstein is quantum phase transition. I think you need to think more about difference between the gas liquid condensation and Bose-Einstein condensation. I think this is a good question. Okay, and this is also a good question of matrix things. And he cannot remember the exact question form, but he can remember, he told me about these things. They asked him about the property of trace. We know that trace of ABC is equal to trace of BCA is equal to trace of CAB. Okay, and they told him to compute the commutation relation of XP. Okay, we know that commutation of XP is equal to H cut I, and they told him to take trace. Okay, so trace of, we see that trace of XP minus trace of PX is equal to H cut D, and this is the dimension of the identity matrix. And if we take trace of XP is equal to trace of PX, from the left side we get 0. Okay, but right side it is not equal to 0. But how can it be possible? It is the main question. Okay, they asked him about this thing. but he told me that he tell me that he could not give the answer correctly. But what is the answer? Answer basically trace of AB is equal to trace of BF is possible only when AB is the finite dimensional. Okay, but when A and B is the infinite dimensional matrix, trace of AB is equal to not equal to trace of BA. XP operator is a infinite dimensional. Okay, so trace of XP is not equal to trace of PX. Okay, so this is very interesting thing. Okay, you need to think this type of things. I think you have to face in different competitive exams or different interview these things. Trace of AB is equal to trace of B only possible when AB is a finite dimensional. When AB infinite dimensional, trace of AB is not equal to trace of BA. You need to think these things. Okay, this is a good question. And at ISCS, he faced these questions. Firstly, one professor asked him how raising and lowering operator acts on quantum states, and one professor asked him to find out the eigenvalues of this exponential I sigma naught n cap theta, and he derived it. Okay, basically any MSc first year student can solve it properly. Basically exponential I sigma naught n cap theta, if we expand it, we get it cos theta identity plus I sigma naught n cap sin theta by from it we can calculate the eigenvalues of this matrix. And they also asked him to plot the graphical question about x log x and sin ix. This is not difficult. These questions are not difficult. You need to practice this graph. Okay, and he also appeared in IIT, but I honestly at that moment I cannot remember the exact name of this IIT, but name is not important, only questions are important. Okay, so in IIT he faced these questions. Firstly, they asked him about ensemble, microscopic ensemble, phase space point, and what is the partition function and significance of its name. And they also asked him about physical significance of wave function psi and definition of classical and quantum gases. Okay, and from quantum mechanics he told me that they asked him about the band structure, metal insulator, and mathematical physics they asked him this question: the property of Dirac delta function, and at which condition Cauchy distribution function tends to Dirac delta function. Okay, I want to say something. Students who are preparing to crack interviews at quantum matter physics or quantum information or related to quantum mechanics, okay, the subject related to quantum mechanics, okay, you need to prepare 4 subjects properly, because I faced that most of the questions I faced from statistical mechanics, and also most of the question I think he also faced from quantum mechanics and statistical mechanics, condensed matter physics and mathematical physics. Okay, 4 subjects you need to prepare properly: condensed matter physics, statistical mechanics, quantum mechanics and mathematical physics. If you prepare properly, you can crack an interview in subject related to quantum mechanics, like condensed matter physics. If you want to pursue PhD in condensed matter physics or quantum information, okay, this type of things you need to prepare to crack this to crack these interviews. You need to prepare these 4 subjects: statistical mechanics, condensed matter physics, mathematical physics and quantum mechanics. Okay, so these are the basically questions I and Alkumitra faced in interviews. Okay, so before ending, one small advice. Okay, so prepare very well on those topics of 4 subjects to crack an interview related to if you want to pursue PhD in quantum mechanics related subjects. Okay, and prepare very well on the topic you choose for your interview. Okay, and be clear why you selected, why you select. Okay, be clear why you select these topics and explain your motivation clearly or confidently, because you have to face this type of question: why do you choose this topic, okay, to pursue in PhD? You have to face this type of questions. So explain your motivation clearly, properly and confidently. Okay, goodbye.